December 6, 1941. Somewhere over the North Sea, Squadron Leader Rupert Clerke pushed the throttles forward on his de Havilland Mosquito prototype and watched the airspeed indicator climb past numbers that should have been impossible for an unarmed bomber built entirely of wood. Through the cockpit canopy, he could see the coastline of occupied Norway approaching at 380 miles per hour, faster than any German fighter stationed there could intercept. The Air Ministry officials who had initially rejected this aircraft as a foolish experiment were about to be proven catastrophically wrong. The mission was simple in concept, but revolutionary in execution. Photograph German naval installations at Trondheim and returned to Scotland without firing a single defensive shot, relying entirely on speed to survive. Traditional RAF doctrine demanded bombers carry heavy defensive armament, armor plating, and self-sealing fuel tanks. These additions increased weight, reduced speed, and still resulted in devastating bomber losses. Clerke's Mosquito carried none of these things. Instead, it carried two Rolls-Royce Merlin engines, producing 1,460 horsepower each. Aerodynamically clean wooden wings and fuselage, weighing thousands of pounds less than metal equivalents, and the radical philosophy that speed and altitude were better protection than guns and armor. 3 German Messerschmitt Bf 109 fighters scrambled from Vernes airfield as British radar operators detected the intruder. The German pilots climbed to intercept what they assumed would be another lumbering reconnaissance aircraft. Easy prey for experienced Luftwaffe hunters. Squadron Leader Clerke watched them climbing below and behind, their relative position confirming what calculations had predicted. At 25,000 feet and 380 miles per hour in level flight, the Mosquito was simply faster than anything the Germans could send against it at that altitude. The Bf 109s burned fuel, desperately trying to close the gap, while Clerke calmly completed his photographic run, turned west, and accelerated toward Scotland. The German fighters never came within firing range. When Clerke landed at RAF Leuchars in Scotland, his fuel tanks showed comfortable reserves remaining. The cameras contained perfect reconnaissance imagery. And most significantly, the Mosquito bore not a single bullet hole despite penetrating deep into German-controlled airspace in broad daylight. Air Chief Marshal Sir Charles Porto, Chief of the Air Staff, reviewed the mission report and photography with growing interest. Perhaps the Air Ministry had been wrong. Perhaps Geoffrey de Havilland's wooden bomber was not a foolish waste of resources. Perhaps the future of aerial warfare belonged to aircraft that avoided being hit rather than aircraft designed to absorb punishment. The journey to this revelation had begun more than 2 years earlier. In October 1938, when Geoffrey de Havilland first proposed a radical concept to the Air Ministry, de Havilland, whose company had built successful civilian aircraft throughout the 1930s, believed that a fast, unarmed bomber built of wood could survive through speed alone. The proposal arrived at precisely the wrong moment. The Air Ministry was deep into expansion programs building heavily armed metal bombers like the Vickers Wellington, Armstrong Whitworth Whitley, and Handley Page Hampton. The idea of a wooden bomber that carried no defensive guns seemed to contradict everything learned from the First World War. The Air Ministry's initial response, documented in multiple official letters now preserved at the National Archives in Kew, was skeptical bordering on hostile. Officials argued that wood was outdated, structurally inferior, and unsuitable for modern combat aircraft. They insisted that bombers required defensive armament to survive. They questioned whether sufficient performance advantages could be achieved to justify abandoning proven metal construction techniques. The proposal was rejected in November 1938. Then again in January 1939, and yet again in April 1939, Geoffrey de Havilland refused to accept these rejections. He had built his career on innovation. Designing and flying his own aircraft since 1908, his company's experience with wooden construction techniques, particularly the advanced use of balsa wood, sandwiched between birch plywood to create immensely strong, yet lightweight structures, gave him confidence the concept would work. The outbreak of war in September 1939 initially seemed to doom the project entirely. Britain needed proven combat aircraft immediately, not experimental designs that might never work. But as bomber losses mounted through late 1939 and early 1940, some Air Ministry officials began reconsidering alternative approaches. On December 29, 1939, the Air Ministry issued Specification B-140th, effectively authorizing de Havilland to proceed with development of what would become the Mosquito. The specification called for a bomber reconnaissance. Aircraft capable of 400 miles per hour at 25,000 feet, with a range of 3,000 miles carrying a 1,000-pound bomb load. These requirements seemed impossible using conventional construction methods and armament packages. De Havilland's wooden design offered a path to meeting them. The contract authorized construction of 50 aircraft, though this would later be reduced to one prototype due to resource constraints, before eventually expanding to massive production numbers. The design that emerged from de Havilland's facility at Hatfield was revolutionary in multiple aspects beyond just wooden construction. The fuselage was built in two halves, like a gigantic model airplane, using a molded construction technique where birch plywood outer skins were separated by balsa wood cores, then bonded together with adhesives under pressure. This sandwich construction provided exceptional strength-to-weight ratio, far exceeding aluminum structures of comparable weight. The wings used similar techniques with a torsion box design that was incredibly rigid yet light. The decision to eliminate all defensive armament was calculated and deliberate. Every gun removed weight. Every gunner removed weight. Every round of ammunition removed weight. The armor protection for gunners removed weight. The turrets that housed guns removed weight and created aerodynamic drag. By eliminating all of this equipment, de Havilland's engineers calculated they could save approximately 2,000 pounds while simultaneously reducing drag by nearly 20%. This weight and drag reduction translated directly into speed, climb rate, and altitude performance that would make the aircraft nearly impossible to intercept. The prototype Mosquito, designated W4050, first flew on November 25, 1940. Piloted by Geoffrey de Havilland Jr., son of the company's founder, with John E. Walker serving as flight test observer. The flight took place from Hatfield Aerodrome and lasted approximately 30 minutes. The aircraft performed flawlessly from the first takeoff. De Havilland Jr. later reported that the Mosquito handled beautifully, felt solid and responsive, and demonstrated performance that exceeded their most optimistic projections. Subsequent test flights through December 1940 and January 1941 confirmed the extraordinary performance. The prototype achieved 388 miles per hour at 22,000 feet. Faster than any RAF fighter then in service, including the Supermarine Spitfire Mk2, which managed approximately 370 miles per hour at similar altitude. The climb rate exceeded 2,800 feet per minute. The service ceiling reached 35,000 feet, range with standard fuel load approached 1,500 miles. With potential for significant extension using auxiliary tanks. Air Ministry officials who had rejected the concept repeatedly now watched test flights with growing interest. By February 1941, Squadron Leader Clerke was conducting operational evaluation flights, including the December 6, 1941 mission to Norway that validated the concept under combat conditions. The Air Ministry began placing production orders. Initially, modest but expanding rapidly as performance and versatility became apparent. The Mosquito's wooden construction offered unexpected strategic advantages beyond just performance. Britain's aluminum supply was severely constrained by submarine warfare, interdicting imports, and limited domestic production capacity. Every pound of aluminum used in aircraft construction competed with ships, tanks, and other war materials. Wood, by contrast, was abundant in Britain and Canada. Furniture manufacturers, boat builders, and other woodworking facilities could produce mosquito components without requiring scarce metalworking capacity. The de Havilland facility organized an elaborate subcontractor network across Britain and Canada. Furniture manufacturers produced fuselage sections, piano manufacturers built wing structures, small workshops created detailed components. Final assembly took place at de Havilland facilities. But the distributed production network made the program less vulnerable to bombing and drew on labor pools, including skilled woodworkers, that were not needed for metal aircraft production. Production Mosquito bombers began reaching operational squadrons in late 1941. Number 105, squadron based at RAF Swanton, Morley received the first aircraft in November 1941 and began training immediately. The squadron's commanding officer, Wing Commander Hughie Edwards, was a veteran bomber pilot who had won the Victoria Cross earlier that year, leading a daylight raid on Bremen. Edwards immediately recognized the Mosquito's revolutionary potential, but also understood that tactics would need to be developed from scratch. Traditional bomber tactics emphasized formation flying for mutual defensive support. Bombers flew in tight formations where their combined defensive firepower could protect against fighter attacks. Mosquitoes carried no defensive guns, making formation flying pointless for defense. Instead, Edwards developed tactics emphasizing individual aircraft flying at maximum speed and altitude, using clouds for concealment when available, and relying entirely on speed to evade interception. The first operational bombing mission occurred on May 31, 1942, when 4 Mosquitoes from No. 105 Squadron attacked Cologne in broad daylight. The mission coincided with the famous 1,000-bomber night raid on Cologne, and the Mosquito crews were tasked with photographing damage while the fires still burned. The 4 aircraft approached Cologne at 25,000 feet and 320 miles per hour. Too high and fast for effective anti-aircraft fire, and too fast for German fighters scrambling to intercept them. All 4 Mosquitoes struck their targets, obtained excellent photography, and returned to England without damage. This mission established the pattern that would characterize Mosquito bomber operations throughout the war. Small numbers of aircraft, sometimes as few as 1 or 2, would strike targets in broad daylight at high altitude and high speed. They would navigate precisely to their targets using the excellent visibility available in daylight and the navigator's position beside the pilot, allowing effective coordination. They would bomb accurately from medium altitude where they could actually see their targets, rather than dropping blindly from high altitude at night. Then they would accelerate away at speeds approaching 400 miles per hour before German defenses could respond effectively. The psychological and operational impact on German defenses was profound. Luftwaffe fighter units had developed effective tactics against RAF night bombers using radar-equipped night fighters that could find and destroy bombers operating under cover of darkness. The Mosquito rendered these tactics largely ineffective by operating in daylight at speeds and altitudes where night fighters, optimized for endurance and radar performance rather than speed, could not compete. Day fighters could reach the necessary altitude and speed, but the warning time was insufficient. By the time German fighters climbed to interception altitude, the Mosquitoes were already departing the target area at maximum speed. German anti-aircraft artillery faced similar challenges. The standard 88mm Flak 37 anti-aircraft gun, which was devastatingly effective against formations of heavy bombers, flying predictable courses at 20,000 to 25,000 feet and 200 miles per hour, struggled against individual Mosquitoes crossing the defended area at 25,000 to 30,000 feet and 352 400 miles per hour. The flight time from detection to target passage was often less than 60 seconds. barely enough time for gun crews to track and engage before the aircraft disappeared beyond effective range. Wing Commander Hughie Edwards flew numerous Mosquito missions through 1942 before being promoted to group captain and given command of a bomber base. In post-war interviews, he consistently emphasized that the Mosquito's success came not from revolutionary technology alone, but from tactics that exploited its unique characteristics. Traditional bomber tactics would have wasted the Mosquito's advantages. The aircraft needed to be flown individually or in small formations at maximum speed and altitude, accepting higher navigation demands and reduced bomb loads in exchange for survival rates. Approaching 99% on many operations, the Mosquito bomber variant, designated B-4, carried a bomb load of 2,000 pounds internally in a bomb bay that was small but adequate for precision strikes against specific targets. This compared unfavorably with heavy bombers like the Avro Lancaster, which could carry up to 14,000 pounds internally and much more with modifications. But the Mosquito's accuracy, achieved through daylight bombing from medium altitude by a crew of 2 highly trained specialists, meant that a higher proportion of bombs actually struck their intended targets. Statistical analysis conducted by RAF Bomber Command's Operational Research Section, documented in reports now available through the National Archives, demonstrated that Mosquitoes achieved target hit rates approximately 3 to 4 times higher than heavy bombers operating at night. A Lancaster dropping 14,000 pounds of bombs at night, with perhaps 20% hitting within 1,000 feet of the aiming point, delivered approximately 2,800 pounds of effective destructive power. A Mosquito dropping 2,000 pounds in daylight, with 60% hitting within 500 feet of the aiming point, delivered comparable effective destruction while requiring 1/7 the crew, 1/10 the fuel, and accepting approximately 1/10th the loss rate. These calculations remained controversial throughout the war. Advocates of heavy bomber strategic bombing campaigns argued that only massive raids could destroy large industrial targets and break German civilian morale. Mosquito advocates countered that precision destruction of critical bottleneck facilities achieved more strategic effect per resource invested. The debate was never fully resolved during the war. Though post-war analysis generally supported the precision approach for many target types, the Mosquito's versatility extended far beyond simple bombing missions. Photo reconnaissance variants, designated PR, I, and later Marks, began operations in September 1941, months before bomber variants became operational. These aircraft were stripped of bomb-carrying equipment and fitted with cameras in the bomb bay and fuselage, along with additional fuel tanks to maximize range. Flying at speeds approaching 400 miles per hour, at altitudes up to 38,000 feet, these reconnaissance Mosquitoes photographed targets throughout German-occupied Europe with virtual impunity. Flight Lieutenant Alistair Taylor of No. 1 Photographic Reconnaissance Unit flew 85 operational sorties in reconnaissance Mosquitoes between 1942 and 1944, his personal logbook, now preserved at the Imperial War Museum, documents missions that photographed targets from Norway to southern France, from the Atlantic coast to deep inside Germany. Taylor recorded only 3 instances where German fighters came close enough to fire on his aircraft, and all 3 attacks were unsuccessful because the Mosquito could simply accelerate away. In post-war interviews, Taylor emphasized the confidence that speed provided. Flying a reconnaissance Spitfire earlier in the war had been terrifying, he explained, because the aircraft was vulnerable to any enemy fighter with an altitude advantage. German fighters routinely positioned themselves above likely reconnaissance routes and dove on Spitfires, which had to twist and turn desperately to evade. The reconnaissance Mosquito changed this dynamic completely. Pilots spotted approaching fighters pushed the throttles to maximum power, simply outran the threat. The psychological difference was transformative. The night fighter variant of the Mosquito, equipped with radar and upward-firing cannons, became one of the most successful anti-bomber weapons of the war. These aircraft combined the Mosquito's speed and altitude performance with a Mk4 or later Mk8 radar sets that could detect German bombers from several miles away. The upward-firing cannon installation, developed by RAF engineer Lieutenant C.C. Williams, and known as Schrijmusik, from the German name for similar installations, allowed the Mosquito to position itself below and behind enemy bombers. Where the Mosquito was difficult to see and where defensive fire was minimal, Group Captain John Cunningham, nicknamed Cat's Eyes Cunningham by British propaganda that falsely attributed his night fighting success to carrot consumption rather than radar technology, flew Mosquito night fighters from 1942 onward and became one of the top-scoring RAF night fighter pilots with 20 confirmed victories. Cunningham's combat reports, preserved at the National Archives, demonstrate how the Mosquito's performance advantages translated to night fighting success. On the night of March 18, 1943, Cunningham was vectored by ground controllers toward a German bomber formation returning from a raid on London. His Mosquito climbed to 28,000 feet and began searching using AI Mark 8 radar at approximately 11:47 p.m. His radar operator, Flight Lieutenant C.F. Ronsley, detected a target 5 miles ahead. Cunningham closed the distance rapidly, using the Mosquito's superior speed to position himself 800 feet directly below a Junkers Ru-88 bomber. The German crew never saw the Mosquito approaching from their blind spot below. Cunningham fired a burst from 4 20mm Hispano cannons, striking the Junkers 88's wing root and fuselage. The bomber exploded, illuminating the night sky with burning aviation fuel and aluminum. Within 15 minutes, Ronsley detected another target. Cunningham repeated the approach and destroyed a second Junker 88 before returning to base with low fuel. Cunningham destroyed a third German bomber using the same tactics. This triple victory in a single sortie demonstrated the devastating effectiveness of radar-equipped Mosquito night fighters against German bombers that were themselves slower and less maneuverable than the Mosquito. Throughout 1943 and 1944, Mosquito night fighter squadrons inflicted unsustainable losses on German bomber formations, contributing significantly to the Luftwaffe's decision to largely abandon strategic bombing campaigns against Britain. The fighter-bomber variant, designated FB-6, combined the Mosquito's speed and altitude performance with devastating offensive armament. 4 20mm Hispano Mark II cannons were mounted in the nose, along with 4.303 caliber Browning machine guns. The aircraft could carry 2,000 pounds of bombs internally, or up to 2,000 pounds of additional ordnance on external racks, including rockets. This combination made the FB-6 extraordinarily effective against shipping, ground targets, and even enemy fighters when circumstances allowed. Wing Commander Robert Braham flew fighter-bomber Mosquitoes with No. 141 Squadron, and later commanded No. 116 9 Squadron, flying anti-shipping and ground attack missions. Braham, who would eventually be credited with 29 confirmed aerial victories, plus numerous shipping and ground targets destroyed, described the Mosquito fighter bomber as the most capable combat aircraft he flew during the war, surpassing even specialized fighters in overall effectiveness. On January 15, 1944, Braham led a formation of 4 Mosquito FBVs on an anti-shipping strike against a German convoy off the Norwegian coast. The Mosquitoes approached at wave-top height to avoid radar detection, then climbed to 200 feet for their attack run. Braham's aircraft fired rockets and cannon at a merchant vessel, striking below the waterline and causing catastrophic flooding. The other 3 Mosquitoes attacked escorts and additional merchant ships. Within minutes, 3 merchant vessels totaling approximately 15,000 tons were sinking or severely damaged, and 1 escort vessel was burning from rocket strikes. German anti-aircraft fire was intense, and Bram's Mosquito took hits in the starboard engine and wing. The Merlin engine began losing power, trailing smoke and shedding pieces. Most aircraft would have been unable to return to base, but Bram shut down the damaged engine, feathered the propeller to reduce drag, and maintained altitude on the remaining Merlin while heading west toward Scotland. The Mosquito's performance was sufficient even on one engine to cross the North Sea and reach Scotland, where Bram landed safely at an emergency airfield. This mission exemplified multiple Mosquito advantages. The speed allowed approach and departure before German fighter cover could arrive from distant bases. 8. The structural strength allowed the aircraft to absorb battle damage and continue flying. The powerful engines provided sufficient performance to return on one engine even with combat damage. And the small crew of 2 meant fewer lives were risked per mission compared to heavy bombers requiring 7 crew members. The most famous Mosquito missions targeted specific high-value objectives where precision was essential and where traditional bombing would have caused unacceptable collateral damage. Operation Jericho on February 18, 1944, aimed to breach the walls of Amiens Prison in France to allow French resistance prisoners to escape before they could be executed by the Gestapo. The mission required absolute precision, breaching walls without collapsing the prison and killing the prisoners who were to be rescued. Group Captain Charles Picard led 19 Mosquito fighter bomber Mark VI from numbers 464-487, and 21 squadrons on the mission. The aircraft approached Amiens at ultra-low altitude to avoid detection, then pulled up to bombing altitude at the last possible moment. The first wave of Mosquitoes struck the outer prison walls with 500-pound bombs breaching them in multiple locations. The second wave struck guard buildings and administrative facilities, causing casualties among German personnel and creating confusion. The third wave was held in reserve, but did not need to attack, as the first 2 waves had accomplished their objectives. The precision was extraordinary. Bombs struck within meters of their aiming points, breaching walls while leaving most prison buildings intact. Approximately 258 prisoners escaped in the chaos, though many were subsequently recaptured, and some died during the escape attempt when German guards fired on escaping prisoners. Group Captain Picard's Mosquito was shot down by German fighters during the return flight, killing Picard and his navigator Flight Lieutenant Alan Broadley. Nevertheless, Operation Jericho demonstrated that Mosquitoes could execute precision strikes impossible for heavy bombers. Another precision mission occurred on January 30, 1943, when Mosquito bombers struck a major Nazi political rally in Berlin. The operation was timed to coincide with the 10th anniversary of Hitler's rise to power. The attack's goal was to disrupt the rally and prove that Berlin was vulnerable to precision daylight strikes. 3 Mosquitoes from No. 105 Squadron navigated to Berlin in broad daylight, arriving at 11 a.m. just as Luftwaffe Chief Hermann Göring began his speech to Nazi officials gathered at the Reich Luftfahrt Ministerium. The Mosquitoes bombed from 20,000 feet. Their bombs struck within 500 feet of the target building. The rally was thrown into chaos. German officials rushed to shelters, and radio broadcasts were abruptly cut. Göring's speech, broadcast nationwide, was silenced mid-sentence, forcing an embarrassing admission that British aircraft were attacking Berlin. The 3 Mosquitoes departed at maximum speed before German fighters could intercept, returning to England without damage. The psychological impact far exceeded the physical destruction. Göring had once boasted that if enemy aircraft ever reached Berlin, Germans could call him Meyer, a common surname meaning he would be a nobody. The Mosquito raid turned that boast into a joke. More importantly, it proved that speed and precision could achieve what mass bombing could not, disrupting Nazi propaganda at its core and damaging morale more than the loss of factories ever could. technological evolution continued rapidly. The B-9 bomber variant introduced upgraded Merlin 70 to 73rds or 76/77ths engines, each producing 1,680 horsepower, raising top speed to 408 miles per hour. The B-16 variant added pressurized cockpits, allowing crews to operate higher and longer with less fatigue. Later, the B-35 featured even more powerful Merlin 113/114ths engines, reaching 422 miles per hour at 28,500 feet. Fighter versions advanced in parallel. The FB-18, nicknamed Tsetse, mounted a 57mm Merlin's automatic cannon in its nose for anti-shipping strikes. Firing 6-pound shells capable of piercing merchant hulls, the Unefati night fighter variant incorporated better radar, stronger engines, and refined aerodynamics, making it the fastest piston-engine night fighter of the entire war. Production matched its success. De Havilland and its subcontractors built 7,781 Mosquitos of all types between 1940 and 1950, making it one of Britain's most produced aircraft. Manufacture continued after the war, with final deliveries in 1950. As several versions remained active in the Royal Air Force and Allied air arms. Operational records speak for themselves. Bomber variants flew about 28,000 sorties, dropping 26,000 tons of bombs. Their loss rate was only 1.8% per sortie, far lower than heavy bombers, which lost 5 to 7% on similar missions. This meant a Mosquito crew had a 95% chance of survival, compared with 85 to 90% for heavy bomber crews. Fighter and intruder Mosquitos destroyed over 600 enemy aircraft in aerial combat, plus hundreds on the ground. Photo reconnaissance models completed 10,000 sorties with losses below 1%. Overall, the Mosquito flew more missions per airframe, with fewer losses per mission, and achieved greater results per ton of material invested than almost any combat aircraft of the Second World War.